Hello everyone, welcome to Gurudakshina. I'm Suresh. Today we are going to discuss about certain scenario that you would have experienced when you migrated from C++11 or 14 to C++17. That is, you might not have seen certain copy constructor or a mover constructor code. Why is it happening? That's what we are going to discuss in this video. So let me demonstrate it with the help of a simple example, right? So let's get into the programming part. Okay, let me write a simple class called my class, and in this class I'm going to write only constructor, destructor and copy constructor. About move constructor I'm not writing right away. I'll be creating another video for move constructor. Why? Because this would be interesting for some of the classic C++ programmers, because they might not be having much of an idea about move constructor. Okay, so let me write the constructor, destructor and copy constructor here, and each these cases I will be just doing some printout statement, because operation is not so important here. We are discussing about why copy constructors or move constructors are missing in some scenarios, right? So here I am writing C2 is called, right? And let me write the copy constructor now. The copy constructor, what I am doing is that the copy constructor is called, so I need to change the syntax, my class. So I'll be writing the copy constructor and ampersand other correct, so const. Okay, so that is copy constructor. Let me write the destructor as well. So the destructor, in the destructor what I will be doing is that again just a printout that deleter is called, right? So my keyboard is behaving weird, sorry for that. Okay, so let's see after deleter is called, right? So here I'll be doing a deleter is called. Let me write another function for that will help us how the behavior is, right? So void, and let me make this as my fun, and in my fun basically I'll be calling my class and an MC object, right? So this is what I'm planning to have it here in the function call, and in the function also I'll be writing function is called, right? So that it will be little bit more clearer. Okay, here I will say my fun is called, right? Now let's create some objects. My class MC, right? So my class MC, I created an object. Let me do one more object creation here, that is, let me make it MC1, which is equal to MC. So here what will happen, a copy constructor will be called in the second line number 70. Now let me make a call MC dot my function call, there I am passing MC1, right? So this is what I am planning to do here. So what we can see in the printout, first constructor will be called, then we will be seeing a copy constructor will be called, then you will be seeing another copy constructor call as a part of this temporary object is created. Then we will be having three destructors, right? Let us see that whether it is happening or not. So let's compile this code. I am using G++ latest compiler and I am executing it. See, as we discussed, line number 16 constructor is called, then the line number 17 copy constructor is called, line number 18 copy constructor is called as a part of function call, then three function call is called, function is called, my fun is called, then three details are called. Let me make a minor change here. Instead of MC1, let me call this class directly a temporary object, and let us compile this and run it. let's see what happens now. See what in previous C++ compiler, that means C++ 14 or below, what will happen in this my function call, a temporary object will be created, then one copy constructor will be called as part of the function call. But when we observe here, see what is happening is that before my function call, one constructor is called as part of the creation of this temporary object, but the copy constructor is not called. Why is it? This is because of a compiler optimization called constructor elision. There are, what does it mean? Like as per C++ 17 standard, each and every compiler, they should do certain kind of optimization for temporary object creation. Okay, so there are a few return value optimization, temporary object optimization, and named object return optimization and all that, right? This is called constructor elision. This is one of the big performance improvement that is introduced in C++ 17 onwards without changing the behavior of the program, right? So that is why we are not seeing a copy constructor call as well as a destructor call. So when we are having a copy constructor, normally we will be having a lot of leaf copies to be done. That is a costly operation. Again, there is a destructor need to be done, right? So this we can avoid with the help of constructor elision. Suppose now you wanted to see the older behavior, right? That means C++ 14 or C++ 11 or the previous version of C++, then we can do that with the help of certain options while compiling, right? How to do that? Let us see that. See, we can have a particular option called no allied constructors. If you compile your code with the help of no allied constructor, and if you run it, now you see the difference. Okay, as we discussed, 16 there is a constructor called, then there is a copy constructor called for the next line, then there is a ctor call for this temporary object, then there is a copy constructor called for this myfun call, then 4 times destructor will be called. So what I mean to say here is that the constructor elision is one of the important performance improvement performance improvement facility that is added in C++ 17 onwards. But if you wanted to see the behavior like earlier, then we can use certain option. You can build and you can see the those codes, whatever missing in C++ 17, that you can see with the help of no allied constructor function, right? Yeah, so thanks for watching. Bye bye.